We're going to continue on with elimination, but what happens when there is no common coefficient? Well, you force it. You make it happen. You make it happen. So you make one of the variables cancel out by making common coefficients. So the rules are the same. We still want my x's lined up, my y's lined up, and my constant terms lined up. That doesn't change. But if you look here, it's not as simple for me. X doesn't cancel out, y's don't cancel out, and before I could just multiply one by, negative to get it to be a common coefficient, but here I can't. So now you're going to identify the easiest way to create a common coefficient. There's always going to be an easy one. I'm going to look at my x's here. You'll notice there's a 2 in front of my x. Well, what can cancel out with a 2? A negative 2. So that means I'm going to multiply this whole top one by a negative 2 to make those coefficients cancel out. So I had to change this top one to a negative 2 to get my x's to cancel out, okay? Now, you can get your y's to cancel out, but y's, that would be harder. I would have to multiply both of them. If I wanted to do that, I would have to multiply the bottom one by 3 and the top one by 7. That way I would create a 21y and a negative 21y, and then they would cancel out. But that's a lot of work. So I just want to multiply one of them. So I'm going to multiply this top one by a negative 2. And remember, if you multiply something, you got to multiply all of it because of the equality. So negative 2x minus 6y equals negative 12. And then I keep my bottom one. Now my x's can cancel out. And my y's are negative 13y equals negative 13. Divide both sides by a negative 13, and y equals positive 1. So how do I solve for x? The same way we've been doing. You take one of your original equations. I'm going to take this top one, and it's telling me that y equals 1. So I'm going to keep the x, I'm going to keep the plus, going to keep the 3, and in place of y, I'm going to plug in 1, because that's what I solve for. Y is equal to 1. So now I get x plus 3 equals 6, subtract 3, and x equals 3. Check your answer. So how do we check your answer? You rewrite both original equations, 2x minus 7y equals negative 1, and now you plug in this point and see, does it make a true statement? If I plug in 3 for x, if I plug in 1 for y, does it create an equation that's true? 3 plus 3 is 6, 6 equals 6. That one checks out. Now I need to check my other equation. If I plug in a 3 for x, if I plug in a 1 for y, does that create an equal equation? Negative 1 equals negative 1. That checks out. Therefore, that is my common. That is the correct answer. Okay? Let's take a look at number 3. All right? Now, there's going to be an easy one to do. So if I look here, I don't want to mess with my x's because then I'd have to multiply the top one by negative 5, the bottom one by 3 to create that common coefficient. This bottom one is 4 and this top one is negative 1. So all I need to do, what cancels out with a 4? A negative 4. So I'm going to multiply this top one by 4 and then watch what happens with my y's. Remember, you got to multiply everything. 12x minus 4y equals 56. And then I keep my bottom one, 5x plus 4y equals 12. So now my y's cancel out, and I get 17x equals 68. And then I divide, and I believe that's x equals 4. Yes. So x equals 4. How do I solve my y? I go back to my original equation, either one, it doesn't matter, and I plug in a 4 for x. So I know that x is 4, that's what I solve for. So this is going to allow me to solve for y. So 12 minus y equals 14. subtract 12. Oh, what am I doing? And I get negative y equals 2, y equals a negative 2. Check your answer. How do you check your answer? You write both original equations, and then you plug in these values. If I plug in a 4 for x, if I plug in a negative 2 for y, does that create an equation that's valid? 14 equals 14, valid. That one checks out. Check this one. If I plug in a negative or 4 for x and a negative 2 for y, does that create an equation that's valid? 12 equals 12, that checks out. Therefore, 4 negative 2 is the right answer. All right, let's take a look at the next page and do a couple of examples here. All right, let's do number 8. Okay, so number 8. There's not one that I can just multiply by. Like I can't multiply the top one by a 4 and then not multiply the second one by another one. So I can manipulate both equations. I can manipulate anything I want. You can do anything you want with these equations as long as you do it across the board. So I am going to cancel out my x's. Would it be just as easy to cancel out my y's? Yep, I'm just choosing x. So I'm going to multiply this top one by a negative 5 and this bottom one by a positive 3, because then I will have a negative 15 and a positive 15, which will cancel out. So I'm going to multiply the top one by negative 5 and the bottom one by 3. Now my x's cancel out. I get negative 3y equals negative 15. Divide both sides by negative 3. Y equals 5. Okay, now how do I solve for the x? You were saying that y is 5. So now I'm going to go back to my equation, and I'm going to plug in 5 for y, because that's what we said. Y is 5. And that is going to allow me to solve for x. Subtract 15 on both sides. Divide by 3. X equals negative 2. And then, how do I check my answer? I rewrite both original equations. And I plug in a negative 2 for x and a positive 5 for y. And I ask myself, does this create a valid conclusion? Does 9 equal 9? It does. It checks out. Now I'm going to do it over here. If I plug in a negative 2 for x, if I plug a positive 5 for y, does that create a valid conclusion? 10 equals 10. That's valid. It checks out. Therefore, negative 2, 5 is my answer.